Alright, the final problems that we're going to look at are problems where you have chords, tangents, and secants intersecting either on the inside or on the outside of the circle, and the situations that that creates. We'll start with number 8. In number 8, we see that we have these two chords that are intersecting, and we can use the relationship that if we take the product of the two sides of the chords, they should equal each other. So if we take 6 times 6, it should equal 9 times x. So we take this part times this part should be equal to this part times this part. And now it's all just algebra. 6 times 6 is 36. 9 times x is 9x. Divide both sides by 9, and I'll find that x should be equal to 4. So that's straightforward enough. Let's look at number 9. Maybe it'll be simple as well. Alright, so we're going to take for this one, since our similar triangles are here and here, we have to take the smaller one times the larger one. Smaller one times the larger one. So I'll start over here. I take my smaller side, 6 times, and then I have to add those together to get this whole thing. 6 plus 4 is 10. Now, I need to set that equal to the smaller one times the bigger one. Well, to get the bigger one, you add these two together. X plus 7 is simply x plus 7. And so now I just simplify this as best I can. That's x squared plus 7x. And now I have a quadratic that I need to solve. You may want to, if you don't remember how to factor, you may want to look up and use the quadratic formula. That will work every time, and is, even though it's complicated, it's straightforward in that you know what to do every single time. If you can factor, however, that's going to be a much faster method, which is what I will do here. So I'm going to subtract 60 from both sides so that I get this situation. And then I'm going to factor this quadratic trinomial that I've gotten. I know I want x times x to give me x squared. Now I need two things that will multiply together to give me negative 60 and add up to 7. So again, those two things must multiply to give me negative 60 and add up to positive 7. The only thing that fits that bill would be plus 12 and minus 5. And so now I can FOIL this to confirm that it actually works. So I get x squared plus 12x minus 5x minus 60. 12x minus 5x would be 7x, and so that works. Now to find my solutions, I take each part of the factored trinomial that we have, and I set that equal to 0. So I can say x plus 12 equals 0. So that means x must equal negative 12, and then I take this part and I say x minus 5 equals 0. Solve that, so x would be positive 5. So there I have two options. Notice up here, this is the length of a side. You're not going to get a negative side length, so my proper answer is that x must be equal to 5. So that's a lot of stuff for one problem. And again, if you don't remember how to factor these, I would use the quadratic formula on this, as it's a surefire way of getting things done. All right, number 10. Number 10, we have a secant and a tangent line. And what we know is that the tangent, the length of that tangent line, is going to be the geometric mean between this part here and the whole part. So when I set this up, I'm going to say that the shorter part, which is 12, so the shorter part of the secant line, over the tangent, which is the geometric mean, equals the geometric mean over, and now I want this whole length for the segment line, so that would be x plus 12. And now, in order to solve this, I can simply cross multiply. 18 times 18 would be 324. And multiplying these two, I'm going to get 12x plus 144. If we subtract 144 from both sides, we find that 180 is equal to 12x, and now we're going to divide by 12 and find that x is equal to 15.